Hello and welcome to International Observe the Moon Night 2018. I am your host, Dr. Pamela Gay, and I am here to put the moon in your brain. We're a little bit late getting started tonight. I have to admit, I have been doing science all day, and wow, my lighting is off. And I was sidetracked by the science. Sidetracked by the science sometimes happens, as does the sun setting, making my light look terrible. Okay, let me see what I can do to bring the lights up to a level that works a little bit better. Okay, I think that counts as a little bit better. Not really. Going to fuss for just a minute. The whole lighting thing. Okay, we're gonna go with that. That is good enough for tonight. I did have to guess up for the funded stream, or more to the point, I decided that it was worth not looking like I'd been doing research the entire day. So I have a tea kettle on. All of you should cuddle up with a good computer, and let's get ready to explore the sky. So for those of you who don't know, International Observe the Moon Night, and my water is about to boil. I've now turned it off. Herleu, I try at the professional, but hey, let's face it, at the end of the day, I'm an academic, so I'm going to do as academics do. Anyways, hello, moon people. We are here to discuss this object, the Earth's moon. This is an object that has been visited by numerous different spacecraft. You see their landing sites kind of scattered all over this image. And we come together as a profession once a year to celebrate our nearest neighbor. This rocky object is lower density than our own planet. It is made of it's made of stuff we have, but in different proportions than the way we have it. This is because of how the moon was formed. We think that the moon was formed out of a roughly Mars-shaped object coming in, hitting the planet Earth, and what was left of these two different objects was one larger object that got to keep all of the higher density materials, and one smaller, lower density object that formed out of everything that splashed up out of the collision. And what got left behind, that was our moon. So this means our Earth and moon didn't form together. In fact, they could have formed as much as 1 billion years apart in time. And we're still trying to fully understand our moon. One of the crazy things, to me at least, is that there are people alive who, when they were born, we had no idea what the dark side of the moon, the other side of the moon, it gets just as much light as the side we see. It actually gets more light because it doesn't undergo eclipses. So there are people alive today who've been alive since before we knew what the entirety of the moon looked like. And we're still trying to develop maps of the moon. The best maps we have are still only measuring objects at 1 kilometer across. Ish. Some areas actually have higher resolutions or higher size chunks than that. So I work with a project called CosmoQuest. Its name is up in the corner there, right there. And CosmoQuest is a place where you can go and help us explore these other worlds. And I'm going to go ahead and get CosmoQuest open for you. And this is a place where you can participate in exploring our solar system. So let me switch views again. And over in the other corner, I have Twitter up. This is a global holiday that's going on. So for those of you who don't know what International Observe the Moon Night is, Observe the Moon, Moon Night, InOMN, it's a global celebration of our moon that started out in 2009 as part of the International Year of Astronomy. And during the International Year of Astronomy, we wanted to celebrate the science of this object that we've actually gotten to go and have human beings stand on. This is the only other object in the entire universe, other than our own planet Earth, where people have visited, walked around, roved around, actually experienced day-to-day existence, for lack of a better phrase. And since then, we have seen, 2009 was when Lunar Reconnaissance Orbiter got to the moon. And since then, we've been able to launch citizen science projects that invite you to help us solve this lack of highly detailed maps problem that we have. So looking over at this interface, our goal is to go through, and this symbol here means crater. Our goal is to go through and, come on, and just mark out where are all the craters located in the image, or at least all the craters that are roughly the size of the cursor or larger. Now, if you're not quite sure what a crater looks like, we have a bunch of examples that you can flip through here on the side. And as you go through all these images, you get to see the moon in all of its diversity. So one of the cool things that I didn't know studying astronomy as I did is our moon has this texture to it that in part comes from the constant oscillations that it has to deal with from being thunked by space rocks falling constantly. The way to think about this is, if you take a big old container of flour and you disrupt the surface. When we're doing this with little kids to help them understand cratering, we throw in gumdrops and then we pull them out. Now, if you have that cratered surface and then you just tap the side of the container on a regular basis, it's slowly going to disrupt the surface. It's going to wear down the sides of those craters. It's going to smooth out the surface. Well, this is pretty much actually happening, but the thing that's doing the thunking isn't, a hand of God thunking the side of the moon the way we might thunk the side of a container filled with flour. Instead, it's rocks, meteorites, small asteroids, occasionally the larger asteroid, falling out of the lunar sky, hitting the surface of the moon, and causing seismic events. We've put seismometers on the moon. We can see that there's this background rain of particles that shake the moon enough that we can measure it, and enough that these craters get worn down over time. You can see that all through this particular image. We throw out all the data from my account, so I have no qualms just going on to the next image and seeing what's going on. And so we can see this amazing texture, these different age craters with different levels of, pristineness is how we refer to it. Pristineness, degradation. And this is our moon. And you can be part of building that map that helps future generations know Where on the moon is it scientifically interesting? Where on the moon is it actually safe to land a rover and go out and just explore? Now, while we're working to map things at CosmoQuest, NASA has a whole lot of different science going on and a lot of different ways that you can explore these different worlds. So let's just take a look at this particular site to give you a couple of different interesting geologic features. And I have no clue why the website picked these two. So to give you one example of a cool feature, we have what's referred to as a skylight. Now, skylights on the moon, on Mars, these are the only two worlds we found them other than Earth, and they are something entirely different once you get off of our planet. Here on Earth, we have skylights. My house has skylights. These are places where someone cut a hole in the roof and covered it in acrylic and plexiglass and actual glass and transparent aluminum. They covered that hole in the roof with something that would allow the sun to shine in and hopefully to keep your house high and dry when it rains. Now, on the moon, on Mars, the two worlds where we've seen skylights elsewhere, the rain, if it existed, would get in. And skylight is simply a place where the top of a cave, in this case a lava tube, has caved in, allowing us to see into the cavern below. The Marias Hills lava tube is one of the largest we've found so far. Looking to see. Nope, no other images of it on here. This particular lava tube is one that some of the Google Lunar X Prize teams have actually talked about potentially dangling a robot into and exploring to see just what's down in that lava tube. How big is it once you stick your robot head inside and look around? Is this someplace where we can potentially go and start to build a safe haven beneath the surface out of the radiation and other hazardous particles and high energy colors of light that are raining down on the surface of the moon? This is the same hope that we have for Mars, and astrobiologists sometimes mention that one of the places most likely to have life on Mars is down inside of the tubes. So those of you talking in the chat, welcome. Welcome everyone, even those of you who aren't talking in the chat. Hello Andy, hello Paranor, hello Fenmil. Who else is out there? Hello Susie. Hello. I think that's everyone who's chatted so far. Yes, all that cheese. The moon is all the cheese, or in reality, all of the regolith and lunar highlands. Hello, Herleu. Sorry that I missed you initially. So in other lunar features highlighted at, sorry, I accidentally went off the site. It's nice to know I'm not the only one that periodically builds websites where you accidentally do that. Okay, so in other news, we also have Linai crater. This is a crater on the moon. We only have this one image again that is apparently a super young crater. The image that we're looking at here in the upper right shows an optical image looking straight down that has a color map overlaid on it that shows the altitude as a function. It just shows altitude. So blue is purple, white is the highest altitude, red is next to highest altitude, orange is pretty much if there was a sea on the moon, what would sea level be? So here we are with our rainbow crater. Paranora, you're right. And this particular crater, we suspect that it's young. It's one of the most pristine that we've seen. Best preserved is another way of putting it. It is about 1.4 miles across, 2.2 kilometers, and it's thought to be 10 million years old. If it were much older than that, the sides would have started to round down like the craters we saw over on CosmoQuest. So it's these pristine features like this that really start to give us a hint of just what fresh craters look like and what happens when big rocks from the sky hit, well, the Earth's satellite. I'm still trying to figure out how to get back to the image I was at before without leaving this website. Okay, come on, website. There we go. That's what I had to click on. Alrighty then. So here we are. I'm going to turn off those geologic features and instead look at the places the robots went. One of the most important ways that we've explored the moon so far is by sending landers and rovers to explore the surface without human beings. This has the benefit of being lighter weight. We don't have to carry oxygen. We don't have to carry water. We don't have to carry the people. Let's face it, you can get away with a robot that's much less massive than I am. Thank you so much, Uncle Bill, for hosting over my stream. So with how dense is a Corvette versus a small meteorite? The small meteorite is much more dense. The Corvette is much larger, and what really matters is total mass versus velocity. It's that momentum, and then the energy you have. So the total mass times the velocity squared. When you're looking at craters and you're trying to figure out what makes them the size that they are, so let's go back to that Lanai crater. So when I look at this crater, what made it 2.2 kilometers across was the energy that was released during impact. And that energy could have been released by a slow-moving, larger asteroid space rock impactor, or it could have come from a smaller object moving at a higher velocity. When the impact occurs, all of the kinetic energy, that 1/2 mass times the velocity squared, all of that kinetic energy gets released spherically. This is why craters are round unless you end up with a super low impact angle. Anything that is more than like 4 degrees up from the surface, it's going to be round. So all that kinetic energy gets transferred into impact energy. It becomes shock waves. It would become sound if it was here on Earth. It becomes heating, transferring of thermal energy, melting of the surface. All these things go on, creating a circular impact crater. Now, since you can get the same amount of energy out of high V, low mass, as you can get out of high mass, low velocity, there's certain things we don't know. We can make estimates. We know in general what is the average velocity of an object hitting the moon. What is the average velocity of an object hitting the Earth? We just know there's variance around that. So we work off of what we know, and it gives us a range of what probably happened. But we don't know exactly what happened. Now, to get back to our man-made, sometimes impactors, we have all the robotic missions that we've sent to the moon. Now, looking at this, we see a variety of different kinds of names. From the US NASA, we have the Ranger missions, we have the Surveyor missions. That's what we did robotically. We sent robots largely in the 60s and 70s, and they gathered rocks. They literally, as the name implied, surveyed the moon. Now, the Russians were along with us for the race to try and get people to the moon first. They gave up. They didn't actually land human beings, but they did land a bunch of rovers and brought back literally tons of rocks. So for them, we have the Luna missions and the Leonard missions. Now, if you're looking at this completely different kind of name up here at the top, Shangyi Yotu, this is a Chinese mission. Right now, the Chinese Space Agency it's a rising star. They've been working on developing space stations. They have a regular manned space program. And what they're working towards in a very concerted manner is getting people back on the moon. And if I were a betting person, I'd actually bet that it would probably be the Chinese who land the first new human mission onto the moon. Now, we have been there. And I know there are folks out there who are arguing, no, you haven't. I don't want to get into that argument because here's the way I look at it. We have the video footage. Yeah, you can argue about it. We have the rocks. Yeah, you can argue about it. But the thing is, we can actually, and I'm hoping this will bring up an image, wrong kind of image. We can actually see the Apollo landing sites. 1 second, and I'll bring you up an image. And the thing about being able to see these landing sites is it's not just NASA images that we're seeing these landing sites in. We're seeing these images in landings. We're seeing these images. Let me start that sentence over. We're seeing these landing sites in images that are coming to us from a variety of different spacecraft. The highest resolution images we've gotten so far come to us from the Lunar Reconnaissance Orbiter. This little spacecraft, which is a twin to the Mars Reconnaissance Orbiter. This little spacecraft is capable of images with resolution such that if a human being were to lay down on the moon and assume the snow angel position, thank you, Andy Cowley, for the follow. If a human being were to lay down on the moon and assume the snow angel position, we'd be able to see them as speckles in the Lunar Reconnaissance Orbiter images. Each pixel is under a meter across for the narrow angle camera images, and in some cases the pixels are as small as 20 something centimeters across in the angular size of what they're able to see on the moon. Now, what that means is this strange, distorted looking blob down here, that is the Apollo 15 Challenger descent stage as seen from straight overhead by Lunar Reconnaissance Orbiter. You can actually make out there's some legs. It's the orbiter, not the orbiter, it's the lander. It's the same kind of thing like some of you may have been lucky enough to see at the Air and Space Museum in Washington, D.C., or to have seen models of at other museums around the United States. These descent stages, these were the jumping off points for a lot of different experiments done by the astronauts. And the reason I brought up the Apollo 15 imagery is Apollo 15 took with it a rover, a car that the astronauts could use to explore around on the surface of the moon, allowing them to get a larger diversity of soil samples and rock samples than they might have otherwise have been able to get. You can actually see, looking through this image, and I'm going to zoom in, you can actually see, looking through this image, the tire tracks all throughout the image. So you can also see, I love the footprints have a distinctly different pattern. So looking through this, you can see how they roved all over the surface, exploring, going, seeing the little craters, seeing the bigger craters, driving around them because they're a bit dangerous to drive through. This is why we need you to mark craters on Moon Mappers. Go to Moon Mappers on CosmoQuest.org. Mark the craters. Save a rover. But anyways, we can see the footpaths left by humans. We can see the rover trails left by humans. And we can even see other bits of stuff left behind. And this is us. This is what we did to the nearest rock in the sky. If China couldn't see this, if India couldn't see this, if Russia couldn't see this, other nations would be screaming to the world, the Americans are full of lies. They never went to the moon. This kind of imagery allows us to see how these surfaces have weathered, how they've changed with time, and allows us to go, yes, at a point in time, before I personally was born, human beings walked on the moon. This is us. And it's hoped that we're going to get back there. It's hoped that we're going to get back there, and not just a few Chinese astronauts, but hopefully this will be more science. This is going to be more rovers. This is going to be more orbiters and people from a myriad of different nations. I don't know if it's going to happen anytime soon. The Space Launch Systems rockets currently being developed by a consortium of different old aerospace companies here in the United States. So you're looking at Boeing, Lockheed, all of the usual suspects. They are working to build massive rockets capable of launching things bigger than we've ever launched before. They will be able to launch a heavier mass amount than what we currently see as the BFR rocket from words lost at SpaceX, the BFR rocket from SpaceX. So once they get it to work, Space Launch Systems rocket will be able to launch more mass than what BFR is currently slated to be able to launch. Now the thing is, they have every single mission accounted for out through the 2030s. There isn't any extra space for any extra cool ideas to happen, for new ideas to be made into reality. But what they are planning on is a deep space orbiter that will be located out near the moon in what we call cislunar space, the space that is between the Earth and the moon. And from this cislunar space, they're going to be able to both send spacecraft to the surface of the moon readily and also use it as a jumping off point. Right now, we don't know as a nation what is our next plan. The goals of NASA do come down from Congress and the executive branch of the U.S. government. And we're waiting to see just what gets funded to go to next. Now, going back to all the things that we can do with the moon, let me switch screens again. We have not just our landing sites, but we also have the ability to study the moon from all the orbiters that go around it. Now, unfortunately, this particular tool doesn't let me tell you all the spacecraft that are currently going around the moon. But for Observe the Moon Night, I have information on how, should you have the weather to go outside, how you can go outside and look up and observe. So go to moon.nasa.gov if you want to get guides to what the moon looks like right now. Ask me questions. Go ahead, at me in the chat so I can catch what you're saying quickly. I just noticed I was missing a question from Scolaris. Or Scholaris. I'm not sure which one you are. I'm going to go with Scholaris. Are there tire and footprint trails visible from Earth with magnification? No, unfortunately not. You just, you can't resolve anything with that level of detail. We can't even do it with the Hubble Space Telescope. We just, the angular resolution that's required to see something that tiny, you have to be really close or have a telescope bigger in diameter than anything we've built so far. One of the problems you run into with building a super large telescope is the moon is super bright. You're going to saturate pretty much any detector you use really quickly. So we have to find that perfect balance. And honestly, the best way to do it is just send a spacecraft there. With Mars Reconnaissance Orbiter and Lunar Reconnaissance Orbiter, we actually kind of got a twofer. They built two spacecraft with pretty much the exact same specs. Sent the first one to Mars, and a few years later followed it up by sending one to the moon. So beyond this, we also have the ability. So they updated this website, and I'm still trying to figure out what all they updated. Okay, I'm going to spend a moment in a different window trying to find what I'm looking for. One should always go to the websites they want to share the day they're going to share them, in case there's updates. I can't tell you how many times this particular failure mode has hit me. So the other place that you can go to explore not just the moon, but our entire solar system is NASA EYES. Now, there's some amazing planetarium software out there. Stellarium is my favorite. It's all free. If you want to find out where the stars are, where the planets are, what asteroids are shooting by tonight, get yourself planetarium software like Stellarium. EYES is not planetarium software. EYES is software that allows you to, let's launch a sample. Nope. No, I wanted to show a demo. More info will work. So EYES is software that will allow you to explore our solar system, and it looks like I need to download it, that will explore our solar system and show you where are the spacecrafts, where are our explorers, where are the little robots figuring things out. So Herleu, I'm so sorry, I'm destroying your username, is asking what other cool moon research is going on right now. If I can get this software to open, I'm going to show you exactly what spacecraft we have there currently. So as I said, we do have the Lunar Reconnaissance Orbiter. The Lunar Reconnaissance Orbiter's primary instruments include its narrow angle camera, NAC, its wide angle camera, WAC. I just love the fact that scientists are literally using WAC images to study the moon. That is a thing. In addition to NAC and WAC images, we also have a LiDAR system that uses laser light bounced off the surface of the moon to very carefully measure the altitude of surface features. So with this LiDAR system, they bounce a whole set of lasers off the surface, and they measure how long it takes for a laser signal to make it back to the Earth, and use that as a measure of height. Oh, it's not going to let me enlarge things. Okay, whoa, that did not go as planned. Sorry. Let's see what I can do here. So let's go with a simple version of EYES on the solar system. It's going to rescale on me. That's what it's going to do. Let's try that. So in addition to those instruments, we also recently had the Grail mission. We had LADI. All these different missions have worked to understand the moon's exosphere, which is the extraordinarily thin atmosphere all around the moon. They have gone to, and I'm going to embiggen this in a slightly different way that is causing problems. Okay. We're just going to go with the craziness. Let's see what I can do to clean this up. Okay, so here we are, EYES on the solar system. Now with EYES on the solar system, this allows us to do things like go and look at the lunar missions. So currently, as you look out towards the moon, in the direction of the moon at huge distances is Voyager 2. That may actually be the coolest thing I've learned today. And I'm actually going to pause for a moment and tweet that because I think everyone needs to know this. So, hey, at observe the moon peeps as you look toward the moon. Voyager 2 is in the background. Check it out in at NASA Eyes? Nope, not finding it. Eyes. NASA Eyes. Okay. And I'm going to screen capture this. And these are the kinds of things that I love learning with NASA Eyes. This is software that brings me no end of silly pleasure. It's not a tool for doing science, for learning science. It's a tool for just seeing what's going on, being an explorer of how things are exploring, which is a bit meta, but that's what you do with it. So currently, looking out at this system, I can see the Laddie mission is out there orbiting around. I don't believe Laddie is still sending back data, but this is a little spacecraft that explored the atmosphere of the moon. It also worked in conjunction with a bunch of amateur astronomers who were observing the moon, looking for bright flashes that indicate that a meteorite hit the moon. And then Laddie observed the atmosphere to see just how much particulate matter, how much dust and stuff got sent up into the moon's atmosphere, and measured, well, how long does it stay there once it gets up there? These are the types of things that we need to understand before we send people back to the moon for any prolonged amount of time. Moon dust. I don't know why I can't get this tweet to tweet. There we go. Moon dust is nasty. It's made out of silica. It will cut you, literally. And there's all sorts of crazy research going on. It's actually wonderful research, but as I describe it, you're going to see why I use that adjective initially. So one of the things we have to do is figure out how to prevent human beings living on the moon from constantly being uncomfortable because of moon dust getting into everything. One of the things they're doing is preventative measures. You get into your spacesuit through the helmet. It closes up as you detach the spacesuit from the spacecraft, and hopefully space dust doesn't get into the spacecraft, but everyone knows moon dust will get into the spacecraft. And so to try and figure out how to make the astronauts more comfortable, there is research going on where they use a surrogate for human skin and take artificial moon dust, rub it into different clothing, and then rub the clothing on the surrogate for human skin and see what gets the most abraded. And so they're essentially torturing not live flesh, so that in the future human beings will hopefully know what to wear. And the answer is not polyester. This is ongoing research, and I'm sure which fibers work best have changed. Last time I caught up on the research, the answer was cotton. So here we are. You can see Lunar Reconnaissance Orbiter is now coming around the bend, allowing us to get a view of the moon from the side the Earth can see. These spacecraft are constantly on the go, maintaining their orbits. So Heptacular Raptor is saying, thoughts on using polarized lens filter when taking pictures of the bright moon. Yes, do that. That will help. Yes. So polarized filters have the benefit of light gets scattered in a whole lot of different directions by rough surfaces. If you're using a polarized filter, you can scatter out all light that is polarized in one direction. This increases your contrast, and it does it as a function of how is light getting scattered off the surface. I am a fan. I am a fan. Looking to see, oh, that's awesome that you did an InOMN sidewalk session, Keeper of Maps. I'm so glad to hear that. And yes, Fenmil, rough silica dust is going to be super nasty on the lungs. And Fenmil, yes, you are right in your guess. So here we are. This is another way you can explore the moon. Now, there's lots of different ways. Thank you so much for this subscription, Tom Van Scooter. I just totally opened the wrong window. Can we get some rockets lighting up the chat out there? Thank you so much. So I'm trying to figure out which one of these windows is the one that I have. There we go. This is the one I want. So, yeah. I recommend getting NASA Eyes. Explore, see what's out there, find out about spacecraft, see what they're up to. And I just find it cool that when you look at the moon tonight, Voyager's in the background. I'm kind of a dork that way. Now, I hope you're all out there mapping the moon. Now, other things you can do out there. Let me find... sorry, they change the names of sites on me sometimes. So the next place that I'm going is the Lunar Mapping and Modeling Portal. This is a way that you can discover the URL changed. This is a portal, once I figure out where it got moved to, that allows you to explore the data that has come down off the spacecraft. Aha, I think it moved to moon views. Is that where it is? No, this is not where it is. Okay, let's try this again. Where am I going? Where am I going? Moon Trek. This is it. Okay, so the Lunar Mapping and Modeling Portal is now Moontrek. And this is a website that once you find it, and I'm going to give you all the URL so that you don't have to go through what I just went through. So, with Moontrek, it will allow you to explore the surface of the moon, skip the tutorial, and see what kinds of data sets we have. And one thing that I want to explain is the reason that the top and bottom of this data set has these massive kind of crazy looking, gestures. I'm recovering from a broken arm, and apparently I don't mouse well. So the reason that the craters in the polar areas on the moon look so weird is it's a round object that's been stretched. So we're seeing those craters disproportionately large compared to the craters that exist in the equatorial regions that have all been squashed in order to see things. So with Moontrek, it totally uses gestures. So I'm zooming in just using my Apple Magic trackpad because I'm an Apple kind of a girl, don't at me. And here we have Copernicus crater. This is one of the amazing double-ringed basins on the moon. If you look at it, to me, it's an angry Muppet. Eyeball, angry Muppet face. But this is one of those regions where you can see just how traumatic the impact of an asteroid in the past was on the moon. This dark material that's located in the floor of the crater, that is material that was melted and float around during the impact. Now, let's look at the different features that we have in here. That is not what I was looking for. Okay, hold on. There we go. Over here, lower right-hand corner now. We have different layers that we can add. So, for instance, there's the menu I was expecting on the left. Lola is some of that laser altimetry data that I was talking about. LRO stands for Lunar Reconnaissance Orbiter. LROC is sorry, I'm just trying to figure out what all we have in here for the different things that I can pull up. Let's see what I can do to find NAC images. NAC. So here we go. You can see narrow angle camera. Let's go to the narrow angle camera of the Apollo 15. Let's see, will it fly me there? Fly to. And I'm going to download. Okay, that didn't quite do what I was looking for, but I now have the image. So this is the area on the moon where the astronauts landed. Still resolving, still resolving. My trackpad may be a little too happy to be alive. Okay, so hopefully that will get added in. This image allows you to see the slopes in the various regions. Why are you singing in the chat? Muppets, that's a good reason. Muppets for every occasion. There really are. In this case, we're seeing the Muppet hair, probably off of Animal. So they have on the lunar modeling and mapping portal, which is now Moontrek, they have all the different images. So here are the WAC images, just in case you didn't believe me that we use WAC images. And this is a global mosaic. This is actually what we're generally seeing in the background of all these images that we're looking for. So let's see what I have over here. Oh man, okay, trying to use my trackpad. Trying not to make a mess of using my trackpad. Failing to not make a mess of using my trackpad. Live TV, folks, or at least live Twitch. So here we go. You can see all the different craters. Now what I'm trying to find is there's some really cool sinuous rills. There we go. So this pattern here, this sinuous rill, these get caused by a lot of different things, but I believe this one is a collapsed lava tube. And it's just amazing to see structures like this on the moon, because we're not used to thinking of the moon as being this kind of a complex object. We're used to thinking of it as craters, not craters, and that's about it. But it turns out it's more complicated. So this isn't a collapsed lava tube. I lied. This is an upward surface, and the way I can tell is this right here is a crater, and you can see the light is on the right side, and here you can see the light is on the left side. Now, where I'm struggling is the light is somewhere different here. Okay, I'm gonna lie, possibly, and rather than do that, I'm going to admit these images are taken at different times, so I can't tell if this is a collapsed lava tube or something pointing upwards. looking at this crater right here. So this crater and this shadow, they match, which implies this is downward pointing. Okay, so we're going to go with where I started, which is collapsed lava tube. We're going to go with collapsed lava tube. Graboid, yes, these are the things we call them here on Earth. So yeah, places that we could live in. It's kind of cool. So the cool thing is we make all the NASA data completely available for free to you. You can go out. These tools are entirely here for you to explore. What questions do you guys have? Are you all, to say it one more time, are you all currently at Moon Mappers on CosmoQuest, mapping out the moon? What science questions do you have about the moon? I'm here to answer them as best I can, and I promise to say I don't know if I don't actually know. I am by training an astronomer. I love Hyptacularaptor's use of emoji. That is fabulous. Looking to see, I'm not seeing any questions. So for those of you who don't know much about CosmoQuest, which I don't know if that's any of you, it looks like we pretty much have the usual suspects. Hey, new people, give us a shout. Let us know that you're here. So Hyptacularaptor has a question. If the moon had a theme song, what would it be? Bluesy. It would definitely be bluesy. I'm going to need to think about this for a moment. It's not Blue Moon. I'm thinking something by Louis Armstrong. The moon just seems like a kind of Louis Armstrong kind of place. Don't ask me to explain that. I totally can't. It's definitely Louis Armstrong, and I'm not sure which song by Louis Armstrong. Susie, that could be it. That's a bit terrifying. Let's see. Yeah, I'm not sure. I just know it's Louis Armstrong. Aquabats would be a proper candidate. I don't know. Are they blues? I don't think they're blues. I don't know why I think the moon must be singing it in the blues. I just feel like that. Okay. Ain't misbehaving? Does that work? Because the moon really doesn't know how to misbehave. Moonlight in Vermont. You got it, Paranor. Moonlight in Vermont. I approve. Okay, so Fedmil is asking, for the metal poor moon, did the core of Theia, is that the proper protoplanet name? Yes, it is. Move into the Earth. So I think move into the Earth is kind of the wrong way to think about it. We had two fairly big things, a smaller version of the Earth and something the size of present-day Mars, slam into each other. Pretty much everything liquefied in the process, everything mixed up in the process. The lighter weight material, probably from both objects, splashed outwards, became the moon. Some of it stayed behind, became the crust. The higher mass stuff, in general, not all of it, stayed behind, formed the core of the Earth. Some of it formed the core of the moon. Some of that lighter weight material just hung out for a while, not sure what to do with itself, waited a while, and then smashed into the back end of the moon, causing the moon to have an off-center center. Its center of mass isn't the geometric center of the moon, and causing the back of the moon to look radically different from the front of the moon. So, yeah. Oh, that's cool that we were able to add something to your Spotify playlist, Heptacular Raptor. Okay. Anything else you guys want to know? Astronomers are literally 1 in a million among humans on our world. And you've got one captive on your screen right now. So please go ahead and ask me questions. And while you're typing those questions in, I just wanted to tell you a little bit more about some of the stuff we do here at CosmoQuest. Now, we are getting ready to go on hiatus until November 1st. We're working on some big plans, big surprises to bring you in the new month and throughout the holiday season. But while this is our last stream until November 1, you can hop on over to CosmoQuest.org and help us map out other worlds any day of the week. That's not going away. Over at CosmoQuest, we're really focused on helping you learn and do science. We have videos, we work in concert with several other YouTube series. The Weekly Space Hangout, Space Hangout Crew is kind of our best buds. Check out wshcrew.space. We work with Astronomy Cast. I'm actually wearing, not that you can see it under my mic, I'm actually wearing my Astronomy Cast sweatshirt because everyone should wear a sweatshirt when going to a star party, even if it's online. And we also work with, like I said, the Astronomy Cast podcast, my podcast, which I co-host. And we make all of our content available for you. Everything is released Creative Commons license, share alike with attribution. This means that if you need something to play during your star party because people are milling around and you're still trying to get your telescope polar aligned, you can throw on Astronomy Cast. If you need something to give out in class, you need some article, and you see what you need located on the CosmoQuest blog, download it and use it. Just give us a link, attribute that author. So we're doing all of this so that you can learn and you can be part of exploration. Anyone can be a scientist. It just takes time. It takes sharing what you're doing with others, and CosmoQuest makes that easy. Like I've shown you, just pop open a browser window and mark those craters. It's easier with a mouse than a trackpad. I am gonna say that. And it's easier with a wrist that hasn't recently been broken than with one that has recently been broken. Don't break your arm, by the way. Just don't do it. It's not fun. I don't recommend it. So, yeah, Paranor's totally right. Everyone is a scientist at some point in their lives. Somewhere along the line, we get the scientist knocked out of us. We get taught to stop asking questions and stop. Let's face it. How many of us have had parents tell us, stop answering questions and go play with your toys? It's a thing. It's a thing that happens. How much more awesome is it when we can ask the questions and we can get the answers, and when we don't know the answers, we can do research to try and find them out. And like I said when I started today, I was late starting the stream because I spent the entire day making plots, crunching numbers, playing with databases, playing with data visualization software. And what I was trying to do was understand what makes you guys, you citizen scientists, do the things you do. Thank you, Disillusioned. That's your second subscription today. Thank you. Yay. Heart. So, yeah. How much more amazing is it to, instead of having nothing answered and being told to go play with your toys, How much better to instead, I didn't mean to click that, to instead, and this is amazing. So this is a shadow. There's something there that's shadowed. Here's a little teeny tiny pristine crater. I think it's too tiny to mark. Oh man, I'm having the worst. I think my mouse pad's running out of batteries. I can't click on anything. Why can't I click on anything? Okay, switching which clicker I'm using. Okay, I'm just gonna give up. So what's super awesome about this is looking at this, we have these two pristine craters, and you see these shock waves through the sand, these linear striations that are moving in this direction. And I'm betting if we could somehow magically zoom out on this, what we'd see is they're related to whatever is causing that shadow. This is geophysics at its best. And this isn't the only world we have at CosmoQuest. We have a bunch of different worlds. That was entirely the wrong thing to go click. We have a bunch of different worlds that you can explore. Oh, so Susie Murph said, Veronica Cure in the chat asked, how do you tell the hills from the craters? It all comes down to which direction are the majority of the shadows lined up. Most of what we see on the moon is craters. The moon has a few volcanoes on it. It has a few natural things that go up instead of a down. Most of them are volcanoes. But the majority of the things we see are craters. And as long as you have light on the same side and dark on the same side, all the objects that look the same are going to be the same innie or outie. Looking to see if I have a bowl that isn't a dirty dish nearby. I think I have one full of yarn. Hold on. Yeah. So this is a yarn bowl. We're going to pretend it's a crater for a minute, because I can also turn it into a hill. Bowls are good that way. And the reason I'm doing this is if the sun's over here, you can see I get a there we go. I have a shadow on one side and light brightly reflected off the other. Now in this case, I have over on this side, which is furthest from the sun, in this case my cell phone, the side furthest from the sun is the side that gets the light. Now if I flip it over and turn it into a hill, it's the side that is toward the light that gets the light this time. So I can reverse which side of the bowl is illuminated and which is in shadow by turning it from a crater into a hill. I know I shouldn't be straining my arm. I am doing more than I should. Thank you for calling me out on it. Oh, can I put myself in a larger window? Yes, let me put myself in a larger window and replicate that. Sorry. Oh, totally the wrong thing. There we go. Okay, so let's try this again. So here we have failure to geometry. There we go. So here we have light on this side, and the light is actually right off the camera. I turn it over, and I can totally reverse the hill and the shadow. This is strangely harder to do than one might wish. So yeah. Hill versus shadow, hill versus crater is all about which side of the image the shadow is on and which side the illumination is on. And the majority of things are going to be craters. So disillusioned, we used to have an indicator showing where the light is. We're going to be working to bring that back. And I'm going to be writing a paper about that. So yeah. cool things in the future. To you guys, thank you for saying it's a pretty bowl. It's a yarn bowl. So do we have any other questions? I'm watching over on Twitter as people are trying to take photos and the atmosphere isn't behaving at most places in the world tonight. It's one of those standard problems we run into. I love some of the random quotes of things I didn't realize I had said. So Pamela is saying, okay, last try CosmoQuest. So why do astronomical objects have so many different names? I understand the different surveys, but why not first survey name sticks? Oh, I know. It all comes down to database entries. It's all about the database entries. So what's going on is, if I write a database, I'm going to give every object in the database an ID number. It's just standard database etiquette. Any of you who use CosmoQuest, you're a database number. I'm database number 4. That's who I am. I am 4. Which isn't nearly as cool as like 7 of 9 or anything like that. So every image also has a number. Every crater has a number. And these are the CosmoQuest numbers. Now, at the same time, I am a number, but I am also a username. So I am number 4, username Starstrider. So with things like the Messier catalog, which is one of the oldest catalogs, it was put together by a dude named Messier. When I was a kid, I'm a bit ashamed to admit it wasn't until I was a teenager that I realized it was not the Messier catalog of objects that look messy when you look at them through a telescope. That's actually a thing I thought for an embarrassingly long period of time. So those objects often have the number that Messier gave them when he stuck them in his catalog. And then they have names like, if you're M51, you're also the Whirlpool Galaxy. And so just like I'm number 4 in the CosmoQuest database, I'm also Starstrider. So you have things that have common names. I'm Starstrider. We have Heptacular Raptor, Keeper of Maps. Those are your common names. Then you have your CosmoQuest name. Now, there's going to be times when I want to cross-list you with another catalog. So, for instance, any of you who have ever used the Bout forums, which are now called the CosmoQuest forums, forums.cosmoquest.org. For a while, there was one login between the two different systems, but we couldn't keep everything secure doing that. So we separated the logins, and now someone can log into both and have different ID numbers, but still have the same username and email address. And so we cross-list people off of both those things. So I can look and see, okay, they both have the same common name. They both have the same email. So that's like looking and saying, oh, they're both located in the same place in the sky. Email is a place. And then going from there, I can go, yep, they've both got numbers. So the problem is, if I look at an object with the Chandra X-ray Observatory and I build an X-ray catalog, I'm going to have or let me use radio. I know radio better. If I look through the NVSS catalog of radio detections made with a very large array in one configuration. These are things that are observed with not a very high resolution, but I can see fairly faint objects. So if I compare an object, and this is part of what I did for my dissertation, that is found in the NVSS catalog with an object that was found by the Palomar Sky Survey in optical light, they might be located at the exact same place. They will have very different catalog numbers because 2 different wavelengths. And then I have to figure out, are they actually the exact same thing. And so they will stay different things unassociated until someone can figure out, yes, they're at the same redshift. Yes, they're the same thing. So we have that problem. Basically, it's just a furry mess. It's just a big furry mess. So most people pick a catalog that's the primary catalog whose names they're going to use. NVSS was my primary catalog for my dissertation. So while I looked at things that were visible in the NVSS catalog, while I looked at things that were visible in the first catalog, when I was identifying individual radio galaxies, if they already existed, I went with the NVSS number. I was searching for galaxy clusters. When I found a cluster that was already known, I used its Abell name first. If it didn't have an Abell name, I used its Zwicky name if the Zwicky name existed. So you have a priority. And all of this mess comes down from not everything is seen in every catalog. And it's a pain in the butt. And we don't like it either. We have a massive database that we use called Simbad, SIMBAD, and we look things up in Simbad, and Simbad will give us all the names a given object has. Let me see if I can demonstrate this for you. Simbad Astronomy. I don't remember where it's located nowadays. There we go. Physically, it's located in Strasbourg. Electronically, it moves around occasionally. So let me switch views. There we go. So let's say I want to look something up by an identifier. I'm going to look up the star Kelt 9b. Submit ID. This is found with the kilodegree extra little telescope. Oh, 9b is the planet. Let me go back and just do Kelt 9. Submit ID. Kelt 9. So Kelt 9 only has, no, it has two names. It's also NGC 2632. So this allows me to find the other names. Now, most things are a bit more exciting than this. So for instance, if I instead look up Cas A. So Cas A, Cassiopeia A, supernova remnant, it's going to give me all sorts of information. So here it's telling me supernova remnant. It's giving me the positions in a variety of different coordinate systems. It's giving me an image of the thing. Parents make sense if you're looking at a galaxy cluster. And it has 43 different identifiers. And this is the kind of thing that makes us hate everything. But because we have massive databases and because so many astronomers like me are basically glorified computer programmers, we can keep track of everything while hating every moment of it sometimes. But at the end of the day, we generally get to then go and study. Let's see if I can zoom in on this. No, that did not go as planned. Okay. Zoom in? Are you going to zoom in? Do I know how to zoom in? There we go. So this glowy stuff, that's associated with Cas A. That is a non-inspirational image. In general, while we have to put up with stuff like Cas A having 43 different names, while we have to put up with stuff like that, we get to study how the universe works, and that's kind of cool. I'm sorry, Pamela, I didn't mean to explode your brain. And yes, it is far worse than people generally realize. Yay! When I was working on my dissertation, Sinbad was just coming into existence, and I once spent an entire Christmas day, because I had a New Year's observing run, just cross-referencing the names of objects. It's a thing you do. Okay, so Paranor is throwing a suggestion for the catalogs, north shared south. Yeah, no. No, we're not going to go with that. So disillusioned, you can actually do in different databases exactly that. Let me see if I can get to the query form for the Sloan Digital Sky Survey, because you can do that. Sky Surveyor. So with the Sloan Digital Sky Survey, it's actually possible to do things like what kind of object something is, where it is, all of these different things. And it's basically just a glorified SQL query that you can type in. I'm not going to risk writing really bad SQL queries in front of the internet right now. I did that earlier today. But yeah, go to the Sloan Digital Sky Survey. Check it out. You can totally query the Sloan Digital Sky Survey to your heart's delight. There you go. Clever use of emojis as always, Hiptacular Raptor. Disillusioned, it's not that bad. Okay, so do we have any other questions out there? And I'm going to hide the sequel because really, I'm going to hide the sequel. Well, Hiptacular Raptor, you don't need shoes, shirts, or anything else to query data on the internet. And this is the cool thing about today's modern online way of doing science is you can have no pants and still do your research. Just don't do it in public. That might be a bit illegal. Yeah. So, it's International Observe the Moon Night. I'm dealing with extraordinarily high winds this evening, so I'm pretty sure if I went outside, I'd get attacked by leaves at high and dangerous velocities. And I don't want to lose an eye to a maple leaf. That just seems like a bad way to go. But any of you who all I want to do is zoom, just shake the stream. Oh, Hiptacular Raptor. I'm not entirely sure what you want me to zoom, but that sounds amusing. Paranor, we do have attacking maple leaves here. It's that time of year. They're falling off the trees. They're quite beautiful, but at 45 miles per hour, that maple leaf has momentum. Anyways, do you guys have any more questions? If not, I'm going to encourage all of you who are on the nighttime side of the planet. The moon's up until about 5 a.m. tonight. And the cool thing about planetary rotation is, as long as you're somewhere with daylight savings time, I'm probably right within about 45 minutes. So you can go out and get cool photos. And Hiptacular Raptor is asking, what's the best way to set a camera up for moon pictures? Now, the nice thing about the moon is it's super bright. So you need really short exposures. What I would recommend is finding yourself a camera that you can adjust how long the exposure is. Zoom in as far as you can, take that super short exposure, and you're good. Now, if you can, you do want to stabilize your camera. For looking at a moon as full as we have tonight, if your exposure is short enough, you may not need a tripod. I'd still recommend one. Now, if you can't zoom in super far and take that super fast click, what you're going to want to do is set up on a tripod and take pictures at a variety of different exposure lengths. You want some of the pictures to barely show the moon. You want some of the pictures to get the moon perfect, and some of the pictures to get the background perfect. And then you can do what's called a high dynamic range, HDR, combination of the images in software. There's stuff you can download to do this on your phone. There's stuff you can download low cost or free even, but the free ones are usually harder to use, on your computer. And that's really one of the best ways to do it, is to take those bracketed images that change your exposure and get underexposed, overexposed, and combine them to get perfect. So that's what I do. Yeah. I personally love my 300 millimeter lens for pictures of the moon. Right now it's cold enough. I'm not going to wear sand shoes. I might just wear snow boots. It's cold out there. So I'm looking to see, there's something going down on Twitter. Not quite sure what's going on. I'm going to switch views so that I can look at this. Okay, let's see what is happening. I'm very confused. Okay, people are apparently... There's two different things going on right now that are strangely competing, and one of them is called the Great Billboard Hunt. I'm not quite sure what's going on, but it's totally clobbering International Observe the Moon Night on Twitter. Okay, and that's what people were complaining about. Okay, Twitter, you're weird. Do you guys have any more questions? Any more good sciencey goodness? And I don't know why my room looks like it's tilted 20 degrees. Yes, clip it and enhance it. Totally true. Yeah, it is Parka season, Paranor. That it is. Okay, so if you guys don't have any more questions, go out, get one final look. Go outside, even if you have to throw on a robe or wander around your house looking for a window pointed in the right direction. It's observe the moon night. Make sure you see it at least once. I looked at it through a window because it's cold and windy out there. And when you're back inside, either go to bed or get online and help us map out the moon. So thank you all so much for joining me for tonight's Observe the Moon Night special. We will be back November 1st. Expect lots of cool new surprises. I'll see you then. Bye-bye.